Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we will understand how to develop program to generate an interrupt for a timer module in STM32 microcontrollers. So let us start the video, but before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and click on bell icon and share these videos to your friends and colleagues. Let us start the video, timer interrupt generation in STM32 microcontroller. So guys, before going to the programming, you should know very important thing. What is the definition of an interrupt and how the interrupt can be generated? So basically, what do you mean by interrupt? So if you see the definition of an interrupt, you see the definition interrupt. An interrupt is a signal generated by hardware or a software. The interrupt is a signal which is generated by either from hardware or software that is going to halt temporarily your main program. So temporarily the main program will be halted and the higher priority task will be handled. Okay, this is called the interrupt. Interrupt means it's a signal generated by hardware or a software that is going to pause your main program temporarily, and it will handle, the processor will handle higher priority tasks which are requested by the interrupt. And after that, you see the next point, once the event is addressed completely, so once the interrupt request has been handled completely, so then the processor will resume back to the main program or a main task where it was working before or where it was executing before. So this process is called as interrupt, and interrupt handling mechanism we will call. Okay, so interrupt means it is a hardware signal or a software signal requested by different peripherals in order to serve very important or critical activities. Okay, that's called the interrupt definition. The interrupts can be generated from various sources. You can see this point here. The interrupts can be generated from either software or hardware. Like when you are talking about hardware, it can be UART, SPI2, CCAN, and so on, even including timers as well. So in today's video, we are going to discuss how to generate interrupts from the timer module. That part we will discuss. Okay, now like how the interrupt will work in a simpler way, we'll try to understand. The blue color, this is your main code, and processor is executing your main code. Let us assume the blue color table, whatever you are seeing, this is your main code and processor is executing your main code. But in the other hand, if you observe here, I have a timer module here, and timer module is configured for 5 seconds. Let us keep it in mind, the timer is configured for 5 seconds. So once the timer completed 5 seconds, it is going to generate interrupt. So that's called as interrupt request. After completion of 5 seconds or after expiring the timer value, the timer module will send a request signal to the processor that it needs a service. So this is called as interrupt request or interrupt signal request to the main program. So once in the main program or the processor notifies a processor receives an interrupt request signal from the different peripherals or from the timer module, so directly your processor will jump to the interrupt service routine, or it's also called as interrupt handler. We will call this part, whatever you're seeing, this is called interrupt handler. So before jumping to the interrupt handler, some different mechanisms will happen. Before directly jumping to the interrupt handler, there is something called as context switch. The very important contents of a program counter, stack program counters, and some interrupt status, your program status information, and other very important information will be pushed into the stack, and that process is called as context store. We will call the program counter and status information and the address where it is executing. So all this information will be pushed into the stack, and then the program control will be loaded with the interrupt service or interrupt handler address, then it will execute. So upon completion of interrupt handler execution or this interrupt service routine execution, your processor will come back to the main program by restoring the context which it was stored before. This blue color part, whatever you are seeing, this is called context restore. So that means your processor will retrieve back from the stack. So here the push will happen and here the pop will happen. So after that, your processor will get the return address and it will start executing your main program. So this is a regular routine of execution of any interrupt of any peripheral, whether it's a software interrupt or hardware interrupt. Okay, I hope this is clear. Now I'll take you to the different what are the different things we have to know in order to do the timer interrupt generation, in order to generate the timer interrupts. So first of all, guys, I have already explained all these things till here. I have explained already in the previous video, like nothing but we need to enable the clock to the timer block, and we need to load the prescaler value, and we have to load the auto reload, and we have to clear the counter, and then enable the counter timer module, and then check for status information. All these things I have already discussed in the previous video. Please watch that video. I'll update the link in the description box. In today's session, I'll be concentrating only on two parts, that is called only this one. So this one, that is nothing but, here you can see DIER. So in our STM32 microcontroller, we have separate dedicated register to enable the interrupt. That stands for DIER. DIER stands for DMA and a timer interrupt enable. So this is the register which is responsible to enable the interrupt from the timer module. Okay, so we have to enable the interrupt from the timer module as well in order to trigger the interrupt. That is the first thing. And second thing, in order to enable, this is the first point. You should know how to enable the interrupt from the peripheral side, and also we have to handle the interrupt, or we have to enable the interrupt from the NVIC side as well. So NVIC stands for Nested Vector Interrupt Controller. This is a interrupt control module which is separately available in our Cortex microcontrollers. So what is this NVIC? In detail I have explained in one more video. Please watch that video as well. Okay, now we have to use the three important things. One is called NVIC enable. NVIC enable IRQ. This is a function or API which is given from the Cortex microcontroller side. So we have to use this API to enable the interrupt, followed by which interrupt you need to enable. So here I'm going to use something called timer to interrupt. So we have to define the which type of interrupt, which interrupt we are going to enable. That information we have to provide. That is the second important thing. Third important thing is we have to set the priority for this interrupt. In order to set the priority, we have dedicated function is available, that's called as set priority. So NVIC underscore set priority, followed by your interrupt name, and followed by the interrupt level what you want to configure. So in this example, I'm configuring timer interrupt as 1 here. Okay. Then finally we have to define one handler. So guys, if you want to do the programming, we have already seen. So we have to enable the clock. If you want to enable the clock, you should use RCC underscore APB1 ENR. So this register we have to use in order to enable the clock. APB1 ENR, APB1 ENR, and then clock, and then I need to load the timer PSC value, TIM2, prescaler value. You can just load with the 1600. So why 1600? In the previous lesson or in the previous video I have explained. You can watch that. Then I'm going to load TIM2. I'm going to load AR register with 50,000. So why 50,000? You can watch my previous video as well. Then I'm going to clear the timer value, timer counter value, CNT. Just you load with a 0. That is going to clear your timer counter. Then I need to enable the timer module. If you want to enable the timer module, I have to use a control CR1. And so this is a regular program what we have already learned in the previous video. Now there is a change. One more thing we have to do, that is called as TIM2 DIER. So this is very important here. Interrupt enable. So this is a register. This is a register DIER, that's called as timer DMA interrupt enable register. Here I need to enable this point, update interrupt enable, right? So this I have to use it. Just bit number 0 it is. I'll create one more macro. I'll be using tim int enable in order to avoid all confusions. Okay, so now I have enabled the interrupt. This much, and along with this, yeah, so I told you two important functions. So that means this is what is the meaning of this? Enable interrupt, timer interrupt. Okay, so now what I have to do, I have to use these two functions. These two functions plays a very important role in order to, this is called NVIC configuration. Two different configurations we have to do. One is a timer configuration and one is NVIC configuration. Okay, so here enable timer interrupt and then assign the priority. It's equal to 1. So this much we have to do in the timer section and in the NVIC section. So two important things. Now I have to define the handler. You can see here, this is the name we have to use, timer2 IRQ handlers. So I'll come back here. I have already declared. Yeah, here you can see. So this is your IRQ handler, line number 113. This is my handler here, and you can do whatever you want. I'll just use UART_str. I'll just write one string here, timer2 interrupt handler. And then this is our interrupt service handler, and then I need to clear the interrupt here. If you want to clear the interrupt, I have to use SR register here. It's equal to, so this is to clear the interrupt, clear interrupt flag. Okay, so like this you can write the code. So now what we did, so you should know a very important thing. This is my handler, interrupt handler, for especially for timer 2, tim2 IRQ handler. And then we have done a timer configuration here. So in the timer configuration, there are two parts. One is regular timer configuration. In the regular timer configuration, just we're allowing to run the timer, and also we have enabled the timer interrupt. Okay, and then second important point is we have to enable the interrupt from the NVIC side. So this is very important. So what is this NVIC and why it is used? All these things I have explained in one more video. You can watch that video. I'll update the link in the description box. Okay, so three things we have done, and I have to define the main code as well. So in the main code, you can see I'm just using UART configuration, timer2 configuration, and this is your main code. Okay, the main timer. Now let us compile this code and check for errors, and if there is any error we will fix it. Yeah, there is no error. Okay, so now I will flash this code. The program has been flashed successfully. So let me open my UART terminal. This is my UART terminal. I'll just connect it. Yeah, you can see here it is working. For every 5 seconds, you can see there is an interrupt. Right, I'll just modify this code slightly. I will add some delay in the main code because it's very difficult to understand here. I'll do small modification in the code, and again let us check the output. I will build it. Okay, then run the code. Okay, now verified successfully. I'll again connect to your terminal. Yeah, now I can see for every 5 seconds there is an interrupt. There will be an interrupt, right? So if there is no interrupt, your main program will run, and if there is an interrupt, the processor will jump to interrupt handler and it will execute interrupt handler, and then it will come back to your main code again. So this complete mechanism is called as interrupt generation, interrupt handling, and then returning back to the main code. In this way, you can use STM32 microcontroller to generate the interrupt from the timer and to handle the interrupt service routine. So if you feel this video is an informative video, please click on like button and share these videos to your friends and colleagues, and subscribe to my YouTube channel. Click on bell icon